guys. So now I'm going to introduce you about our lab, the robotics lab here, and I'll introduce some of the robots also here. So this is room number 123 of engineering building here in University of Detroit, Mercy. You can see our lab. Nobody is here actually now due to this pandemic, but these are the space for you guys to work. And coming back to here, you can see number of robots here. See, we have mainly 4 different types of robots. So if you come here, this is the Pioneer P3Dx. I think you already got an introduction about Pioneer in our last session. So this is Pioneer. I'll explain you more detail about the Pioneer today. And next session we'll be discussing about the Jacquard. So this is the Jacquard. Okay. The main difference we can see, this Jacquard have 4 wheels, but the Pioneer you can see only 3 wheels. I think in AMR session, Dr. Mohan will explain what's the difference between a differential wheel and a skid steer wheel robot. And you can see here, this is also from Mobile Robotics, same company from Pioneer, and its name is Pioneer P380. So this is also a skid steer robot. And coming back to a big robot, like all these robots are for indoor applications, okay, inside the laboratory and all. But if you need to go out for doing some projects outside, then you need to have big robots, okay. So this is also from the same company called ClearPath, who are manufacturing the Jacquard. His name is Husky. So you can see it's big comparing to other robot, and it is having a big wheel. And this one is also a skid steer robot. So now I am going to introduce you the Pioneer robot, Pioneer P3Dx. Okay, as I told you, it's a differential robot. You can see 3 wheels here, and I just kept 3 robots here. I'll let you know why I kept 3 robots later. Here, if you see this robot, you can see 3 wheels. So 1, 2, and at the back side, you can see a caster wheel. Okay. So this one is actually the differential drive robot. Now, I'm going to open the top plate of this robot just to introduce you what are the components inside the robot. Okay. So there are some screws here. I already took it out. So now I just took the top part down. So this is the internal structure of the Pioneer robot. Okay. We have 3 batteries here. There is compartment for 3 batteries. So this is one of the battery. This is a 12-volt 9Ah battery. Okay. So we have 3 batteries installed here. So 12-volt 9Ah batteries. Okay. This is the motor driver board. You can see this one is the motor driver board, and this is the power supply distribution board. Okay. So basically this battery, all the batteries are connected to this board together. Okay. It's actually a parallel connection. Okay. And if you come to this side, you can see a board here. This is the ultrasonic sensor interface board, and these are the ultrasonic sensors. Okay. And I'll show you the front side of the ultrasonic sensors. So this is the front side of the ultrasonic sensor. Okay. And this is the inner side of the ultrasonic sensor. And these sensors are interfaced to this ultrasonic sensor interface board. And this one is the microcontroller board on this robot. Okay. So basically 4 boards here: the power supply, the motor driver, the microcontroller main board, and the ultrasonic interface board. Okay. And if you come here, these are the 2 motors attached to the wheel. Okay. So wheel 1 and wheel 2, and this microcontroller will get commands from the computer. Okay. And this microcontroller will drive this motor through this motor control board. Okay. Clear? status LED will be green. You can see here it is blinking green now. Okay, and there are two more buttons here, the auxiliary 1 and auxiliary 2. So that can be used for customized connection, like if you need to control any other sensor, you can use that buttons. Okay, and two more LEDs here. You can see RX and TX. That will be indicating the serial communication. Like once you start sending some commands to the Pioneer from the computer, this will start blinking. This is a default thing with the serial communication. There will be TX bits and RX bits, right? Same thing. This one is just to indicate that. Now, so that is all about the connection between the computer and the Pioneer. Okay. Next thing, we are going to interface number of sensors, right? So basically, we from our department insist our students to interface basically two sensors. Okay, so the LiDAR, okay, and a camera. I think you guys remember day before yesterday during our session, I show one photograph of the Pioneer with the different sensors, right? This is the same Pioneer. So this is a LiDAR, okay? And this is a Kinect Xbox camera. I think you guys are already familiar with the Xbox camera, okay? So the specialty of this Xbox camera is it's having stereo vision. Like you can detect the depth, that means the distance from the camera to the obstacle. Okay, so this is a very good sensor for robotic application. And the LiDAR, as we know, that is also can be used for detecting obstacles. Okay, and this is the main sensor, the common sensor that we are going to use for navigation, G mapping, and all. Okay, so this LiDAR is from Hokoyu, a company called Hokoyu. This LiDAR is connected to the NUC through the serial port. You can see this is the LAN port. Okay, so this LAN connection, I'm connecting to the NUC here. So that one is done. Okay, and the power to the LiDAR, again, we are taking from the power supply distribution board that I explained you earlier. Okay, same board, we'll take an extension 12 volt and we'll be powering the LiDAR. And about the Kinect camera, same thing. We will be powering the Kinect camera 12 volt from the battery, and the output of the Kinect camera will be connecting to the NUC using the USB port. Okay. Now we are going to drive the Pioneer robot, just to get a brief idea how the robot will perform. All those things I will show you now. Okay. As I told, there's a computer, NUC computer on our Pioneer, right? So this computer I have connected to my laptop remotely. Okay, this is my laptop, and I just connected this laptop remotely to the NUC, the computer on the robot. So if you come here, now you can see is the NUC computer on the Pioneer. Okay, and I am going to launch the launch file. So don't worry about launch file as of now. We'll explain you what is the use of launch file, how it should be used, all those things. Okay, but just know that we are using ROS here. Okay, so for our Pioneer we have a ROS package. We downloaded the ROS package on the computer which is on the Pioneer robot, and we connected all the hardwares, and we use the launch file to launch the Pioneer robot. That's it. Don't get confused. We'll teach you all those things, how to launch and all. And you can see all the documents in the Sakai website. Okay, we already shared. So if you go to Sakai website and see Pioneer P3Dx documentation, you will get to know what are the different steps we followed. Okay, but you don't want to worry about all those things now. Just I need to show the demonstration on the robot. So now I'm going to teleoperate the robot. I think last class I explained what is teleoperation, right? So we can control remotely from the keyboard, from our keyboard. So I am going to control that Pioneer robot remotely from my laptop. Okay. So now the teleoperation is going to be performed. So from the keyboard, I'm going to use the arrow, okay, up arrow, down arrow, left and right arrow, okay. So you can see now here, I'm going to press the up arrow. So we can see the Pioneer is moving forward, okay. And if you need to turn, I'm just pressing the right arrow, okay. And if I need to turn to the left side, I can do that from the keypad. Also, if you need to bring the robot back, you can hit the back arrow, down arrow. Okay. So this is just a basic operation. So I think you got a feel like how we are going to work, right? So we will be having different packages for different sensors. As of now, I didn't show anything about the LiDAR and the Kinect camera. All those things we'll be teaching you in the later sections. Just for demonstration, I just launched the basic Pioneer launch file, okay, and I connected the NUC computer on the Pioneer to my laptop, and from my laptop, I am remotely operating the Pioneer. So, day before yesterday during our session, I explained you right about autonomous robots. So here, as I told, this is a teleoperated robot now, right? So you will be developing some autonomous algorithm, okay, which does not need any human intervention, okay? Yeah, that's it from my side. So if you have any questions about Pioneer, please let us know, okay? And we'll be sharing the operator's manual, the user manual with you if you have any doubts, okay? And also in the Sakai website, we have the complete documentation of the Pioneer. And if you need more videos or presentations, just type in YouTube for Pioneer P3Dx so that you will get n number of projects based on Pioneer P3Dx. Thank you.